We begin our exploration of conic sections with the circle. So let's talk a little bit about the circle. The circle was actually covered in section 1.2 of your textbook. So we are taking a really big jump backwards to pick that up, but it just seems to fit better with conic sections since that's what it is. So let's talk about a circle, and we're going to start our discussion with a review of a couple of formulas, the distance and the midpoint formulas. You may or may not have talked about these in Math 171, but you have definitely seen them at some point in your mathematical career. So the distance formula says this: given any 2 points, P1 and P2, given by the ordered pairs here, the straight line distance d between them is given by this formula. And we have used this formula in doing some of the proofs of our trigonometric identities. So you have seen this formula more recently. The midpoint formula, maybe not quite as recently. Again, if you've got 2 points and you're trying to find the point or the ordered pair in the middle of those two, then what you do is you add the x's and divide by 2, add the y's and divide by 2, which makes sense. You're taking the average of the x's, the average of the y's, and that's going to be the midpoint. So let's suppose that we have a circle with endpoints of a diameter at -4, 3, and -1, 7. And just to remind you, a diameter has endpoints on the circle and it passes through the center. So it stretches all the way across the circle going through the center. We are asked to find the center of the circle and the radius of the circle. Well, the center of the circle should be at the midpoint of these two ordered pairs. So we find our midpoint by saying x plus x divided by 2 and y plus y divided by 2. So the midpoint of that segment is going to be -5/2. 10 divided by 2 is 5. And that is the center of our circle. The center should be in the middle of the diameter. So we found that center there. Now we're asked to find the radius of the circle. The radius is the distance from the center to the outside of the circle. So one option is we take our center, which we just found, and we go either to -4, 3 or to -1, 7 and find the distance. Now that would work perfectly fine. One thing that I would kind of throws up a red flag to me is like, that means I'm going to have to be dealing with fractions, and that can be kind of annoying. So is there a way that I could avoid the fractions? Sure. I could actually find the length of the diameter and then do what to it? Divide it by 2. So I could find the distance from -4, 3 to -1, 7, or in the other order, it doesn't matter. And then when I get that answer, divide it by 2, because that answer is the length of the diameter. We're looking for the radius. So the diameter, D stands officially for distance, but this distance that we're finding is the diameter, would be equal to the square root of. So we are choosing, or I am choosing, option 2. The distance from -4, 3 to -1, 7 is the difference in the x's squared plus the difference in the y's squared. Now, if you were thinking, Ms. Hall, shouldn't you switch that and change the order? I could. The reality is, in the distance formula, the order that we subtract the x's in and the order that we subtract the y's in doesn't matter, because it's just the difference of a sign, and we're going to square it anyway, so it's going to turn out positive. That's different from, say, the slope. The order matters very much in the slope. So in the distance, not quite so much. All right, so we will complete this. -4 minus -1 is -3. Square it. 3 minus 7 is -4. Square it. So we get the square root of 9 plus 16. Square root of 25, which is equal to 5. All right, that's the diameter's length. That means the radius would be equal to 5/2. Now we want to start drawing some conclusions about circles and their equations and things like that. So I want to point something out to you. The circle in question had a center at -5/2, 5, and a radius of 5/2. Okay? I want you to notice something. Here's the equation of this circle in what we would call standard form. Okay? Notice some placement of some of these key pieces of information. The x part of the ordered pair is -5/2. This has a +5/2. The y part of the ordered pair is 5. This has a -5. Can you think of a time where you've seen kind of opposite behavior of what you would expect between an equation and a graph? You have seen it in Math 171 with graph transformations. Whenever a quantity is inside some parentheses, it behaves with the opposite sign. So when we see -5/2, that translates to +5/2. When we see a +5, that translates to -5. And the radius was 5/2. It's related to this quantity. Notice that this is the radius having been squared. So be on the lookout for those connections in future videos.